Hello, my name is Rafał Pocztarski, and my talk is titled "Call Me Irresponsible If I Ever Crash on Null or Undefined in JavaScript or TypeScript." You may know me from Stack Overflow, from Medium, Quora, and other places. Some people more recognize my avatar than me personally, so I always start my talks with that. And recently Quora scared me. I was scared that my followers disappeared because I saw that I have 404 followers. So this shows you how used we are to certain conventions. Okay, so the talk is titled "Call Me Irresponsible If I Ever Crash on Null or Undefined in JavaScript or TypeScript," but it should actually be called "Just Call Me Irresponsibly If I Ever Crash on Null or Undefined in any language," or if I ever crash, for that matter. So the title was inspired by an old song about irresponsible software development that some of you might know. And I have a question for you for the start. Who of you has ever designed a network protocol? Okay, so not many people design network protocols. And another question, who has ever been in a dialogue like this, discussing an endpoint with someone, like a front-end developer discussing an endpoint with a backend developer? Yeah, more people, but what is my premise today is that this actually is designing a network protocol. This is just a different layer of the protocol stack, and those are just like edge layers of the protocols. And this is a simplified model of a typical protocol stack in a usual front-end, back-end application, like a web application. There are a lot of protocols in between. There are not of them are even listed here, and there are several access points and routers in between. But at the top and at the bottom is actually an implementation of our custom REST API that we discussed. Usually a front-end developer with a back-end developer. There should be probably a specification at the beginning, but in practice, some people just start with a single endpoint and go from there. And my idea here is that we should treat it just like any other layer of networking protocols. And I called it simplified model because I didn't discuss everything here. There are a lot of other things. My slides will be available for everyone. At the end, there will be a URL, so you don't have to read everything. But this is a simplified model of a typical stack. So that's the client implementation of our custom REST API and the server's implementation of our custom REST API. It is very useful to know all the layers in between, because in every of those places something can go wrong, and usually does. So you need to understand it to debug it in production. So this is like a like a mountain of obstacles in between. Before we usually think about just calling an endpoint and getting an answer, but what happens in between is usually what can fail, what can be not performant, and what needs to be taken into account. But here I will just want to discuss the edge layers of that. So just the REST API. And since we look at it that we are indeed designing a network protocol, then we have several nice documents to read about how to do it well. And I would recommend everyone reading the RFCs 1122 and 1123, because if you start thinking about designing a RESTful API in terms of designing a protocol, then there is a huge amount of knowledge that you can build your experience on. And some of the quotes from those documents are that software should be written to deal with every conceivable error, no matter how unlikely. This is a lot of people just think that, oh, it's something very unlikely, so I don't have to do it. But no matter how unlikely, it will happen someday. So you need to be prepared. The most serious problems in the internet have been caused by unenvisaged mechanism triggered by low probability events. So those low probability events are things that keep us awake at night or stay late on the weekend, and because everything works for me, but there are some circumstances, very low probability events. And even if a protocol specification defines 4 possible error codes, the software must not break when a 5th code shows up. So this is also something that people don't take into account. If we agree on some, I don't know, possible response codes or response values in a RESTful API, then we cannot crash if we get anything else than we expected. And the most important thing I think I would like everyone to remember from this talk is the robustness principle. Be liberal in what you expect and conservative in what you send. It means that pretty much your code should always produce correct data, but your code should always accept incorrect data and not crash on it. It can, of course, give some errors, handle some exceptions, but it cannot crash. So you need to be, so to speak, expecting unexpected format, unexpected types of data, or unexpected data or error codes that you haven't thought about before. And in our RESTful API example, this usually means that the frontend must always send proper requests with correct data, but if it doesn't, then the backend cannot crash. And the same goes for the backend. So the backend must always send proper response with correct data, but if it doesn't, then the frontend cannot crash. And some of the more problematic problems that I've seen in some production applications could be really avoided if people were sticking to those rules, because when on a Sunday night a client calls that his application in production it just crashed and nothing can be done, then the blaming war starts. So the front end crashes, but it's not the fault of the front end because they got bad data, but the bad data was not the problem of the backend because in the database there was something unusual. So this is something that I've seen in production, and I actually spent some sleepless night on. So going back to the "Call Me Irresponsible" song, there are usually the excuses that are played on problematic events of people just getting information about crashing just soon before they want to go home or start the weekend. So that's also why you shouldn't deploy on Friday. But I once seen that people who had a policy to deploy on Thursday, then everyone was very calm because there's still Friday. If we cannot do it today, then we'll just do it on Friday, and the situation was pretty much the same. So, has anyone of you seen errors like this? And never, yes. So that is, I think I will need to explain it. So I personally, I love the last one, the undefined is not a function. So I almost like, oh yeah, I forgot that undefined is not a function. It's like I need to find, when I call undefined as a function in my code, remove it, and it will just go right. So, but all of those errors, like cannot read property to lowercase of null, or cannot read property map of undefined, or users for each is not a function, or just undefined is not a function. Those are usually things that I see when the client calls and the application just crashed. Everything is just a white page and we just cannot do anything. So something like this usually happens. And one of the common thing here is that this is a type error and that this is a runtime exception. So we have a runtime exception of a type error, and today we have a lot of tools to avoid things like that. So, and of course, null is called $1 billion mistake by its inventor. And in JavaScript, you have both null and undefined. So we just we are very lucky. I don't think any other language. In Perl, there is undef. In a lot of language, there are languages where there is no null or undefined value, like scheme or things like that. But we have both. So we have we are twice as lucky. And this is an actual quote from an issue on GitHub in a production application that actually crashed, and the weekend was like a disaster. We were working, all day and night to find some things, and I won't go into details, but this is the actually quote that I read from a developer whose code was crashing, and the crashing was caused because he expected the response from the backend that he got. He expected to have some values, and one day it didn't, because the client migrated some database that didn't have some data for all of the users that previously everyone had the data. So the developer assumed that it will always be true that I can access some property from the JSON that he got from the API. And one day there was no data and the application completely crashed. And he was arguing with me that this is not the fault of the front-end code, this is the fault of the backend, because the change of the backend actually created the crashing of the front-end. So, and I was thinking about, because this is actually a very good example, but that, yeah, of course, you cannot blame the car engine if you put the wrong kind of fuel in the car. But I immediately imagined two possible things that can happen. One would be saying like, engine malfunction. Oh yeah, I put the wrong fuel, I need to pump it out or something. And it's like a tough day for me. But the other reaction of the engine could be a little different. So this is more like, not just handling the error, but just exploding. And of course, the explosion would be probably initiated by me putting the wrong kind of fuel, but I think I would not like to die in such a car, but just I would like to see the dashboard telling me that I just cannot drive and I have to go to a workshop. So this is actually a good example that I always remember, because yeah, this is not your fault that the backend gave you bad data, but it is your fault that you crash on bad data. And actually the fix was very easy, and it seemed that the front-end code was actually checking if something is missing. So there was a code to put some default value if something is missing, but of course this works when the C is not there, but it will crash if the B is also not there. So the correct way to fix it was just to change it to, this is from the get from the Lodash library. So this is not even much, more writing, but you just have confidence that it will never crash, no matter how if there is no B or there is no C or anything. So this is that. Oh, I see that I have a backtick left there on at the end. So this shouldn't be there. So this is what I recommend doing to everyone who gets any data from the external of their own code. And usually people think about user provided data, like you have some user input like username or things like that. We are used to expect like an SQL injection there, or just too long data. Someone could send like 100 megabytes of worth of a username, and we cannot crash when it happens. We just need to handle that. But people rarely expect that actually the response from the API that you got, the front-end code that makes a request to the API and the backend sends some data. This is also an external data. So you also should be checking if something is available before you access it. And all of the errors that I showed on the previous screenshot from the developer tools was about pretty much nulls and undefineds. So undefineds are usually, there is no undefined in JSON. So when you have undefined in JavaScript in data that you got from JSON, it usually means that the property was not there. Null can be in JSON, but you have to handle both of those. And the question is, and since it is very easy to actually handle situations like this, the question is how to make sure that it's impossible to make a mistake like this. And we have a lot of great tools for that. So first of all, I always recommend to use TypeScript with maximally restricted configuration. And by which I mean really no implicit any, no implicit this, always strict null checks and things like that. So it makes, some people complain that it makes writing harder because you have to explicitly define the types of things, and also people are not used to, because they are used to languages like Java where every type can be really also null. So if you declare a type of I don't know, a string, then it can be a string or null. In TypeScript, we can exclude nulls and undefined from types. So we can reconfigure it. This is unfortunately not the default. So that's why I'm recommending to restrict the compiler configuration more than the default. And we can configure TypeScript compiler to exclude null and undefined from all the other types. So this is not implicitly included in a string, in an object, or any custom type. So when we have a value declared as, for example, a string, then it cannot accept undefined or null. This is not what we are used to, but this is very useful to make sure that we can then we always know when something can be null, because by default, when we declare, for example, a function argument in TypeScript as a string, then we can call, for example, the toLowerCase method on it, but we cannot have any knowledge of whether or not someone will pass null to that or undefined. So to make sure that it's impossible, then we have to restrict it somewhat. Also, I recommend using tslint with some other restrictions, and there is a very good configuration for tslint. It's called typestrict. I don't know if anyone has used it, but this is like a configuration of tslint focused on maximizing type safety. So it doesn't tell you how many tabs or spaces to put anywhere or anything like that. No formatting rules, but just rules ensuring that you are as type safe as possible. Another thing that I always recommend doing on both backend and frontend side is data validation, and all data from outside should be validated before use. And I mean, if you are writing a backend code, then all data coming from a request should be validated. This is usually pretty much understood by people, but people rarely validate the response that they get from another API. Because they read the documentation, they see how everything should look like, and they just assume that the values always will be there. And I always recommend also validating the this is not very difficult to do. It's just like validation, or just using ready libraries like lodash or underscore or Hawk from the Happy framework, where you just access deeply some properties of an object, but with a guarantee that it will never crash, even if anything in between is not there. Soon we will be able to use the new operator for that, but I don't know if it will work for both null and undefined. So, but there are libraries to do it. So the most important thing is that the application must not crash on unexpected data. So it can show an error, it can complain that it cannot do something else on it, can print some default values, some placeholders, but it can never just crash. And because at that point the client calls you at the middle of the night and just nothing works. And this is really hard to do sometimes, because, for example, I had some problem once when the solution was to log out and log in, and it was fine, but no one could log out because the application was crashing, and even the logout button was not there. So it's sometimes it's just never crash, even if the application cannot do anything useful. It can never crash. So one of those, and one of the most typical errors, are just handling nulls and undefineds, or just non-existent values, and you always have to test it before you use it. And as I said before, some language, some type system like TypeScript can catch null-related bugs in compile time before you even run the program. So this is very useful. And actually, even the code editor, the text editor, can underline for you something like, that you are calling toLowerCase, but you cannot, because this can possibly be null. So first check if it's not null, and then it will let you do it. And it's even quite smart. For example, the Visual Studio Code works very well with that. When you have restricted TypeScript, strictness, that it underlines. Sometimes you just think that you misspelled the method, like two lowercase, because it's underlining it, but it turns out that it's telling you that it can be undefined here. So first check in an if, and the editor is smart enough to know that inside an if block, then it's fine. Outside, it's not. So I would also advise to use type systems, static type system, whenever you can, like TypeScript or Flow, or there are other language compiled to JavaScript that you can use as well. And just to always do anything to catch nulls, undefineds, missing on or incorrect data or anything. And every time you see a type error at runtime, when you are using TypeScript or any other statically typed language, then you are doing something wrong. Then it can be avoided. Because if you have the types defined at the compile time and checked well, then it's impossible to really have anything at runtime unless you are, for example, using a JavaScript library with your TypeScript code, and it can never send you correct data. But even it's not statically typed, the library that you are using, but you can still write some function that gets possibly incorrect data and returns validated or transformed data with another type that you can accept in other places of your code, and that way you can make sure that you never get any unchecked types or objects or anything like that directly in some other places. So this is usually when you are using TypeScript and you have a runtime type error, then you can fix it and never have those errors. And those are one of the most common errors that I see from things that actually crash in production, because usually that code should be well tested, everything is fine, but at one time the client decides to migrate his database, and the new data doesn't have something that the old data had, and the backend doesn't include something, and either the backend crashes or the frontend crashes later, or something like that can happen. And if you always check the data, and if you always have the mindset of checking every data that is outside of your program, and it's not only just user input, but it's also API responses, it's also database query results, and anything like that, then you can be pretty safe from that. Another thing is to use static analysis tools like linters and other software that can detect errors other than just the compiler, so like tslint in that example, and to make sure that you run it on the CI, so that you don't only run the actual unit tests or integration test on your continuous integration system, but also to run the linters, because sometimes people will forget to lint the code before checking in, before making a pull request, and that way you can not only make sure that the style is consistent, like spaces, tabulators, and things like that, but also that you don't put any potentially unsafe code in the repository. So the application cannot crash. There are no exceptions, and by which I don't mean exceptions, because there are exceptions and you need to handle the exceptions, but there are no exceptions to the rule that you cannot crash. And this is like the most important thing, that if your code crashes, if anything crashes and the git blame shows that it's your line, then you should be quickly finding a way to make it never crash again, because data will always change, something weird will happen in the future. You don't know what will be in the database a year from now, and you cannot really make any assumptions. You have to test everything that goes from the outside of your application. And this includes getting data that you don't expect, wrong types of data, size of data, no data, errors instead of data. There are a lot of things, and blaming the conditions that led to the crashing, which I see quite often, unfortunately, is like, someone is, for example, I see that git blames shows that it's my code that is crashing, but it's not my fault because I got a bad data. Someone, wrote a too long username, so it's not my fault. So this is always my fault. So just so you know that when your code crashes, when there is any uncaught exception, then it's your fault that you didn't think about it. So And this is actually an actual conversation that I had with one of the project, that in a code review of a pull request, I wrote that you don't handle an exception here, and the author of the pull request told me that, but this will almost never happen. And so I wrote that, yes, that's why it's called exception. So exceptions are things that will almost never happen, but they will happen in the worst possible time, unfortunately. So I have a lot of resources in those slides. I think that actually the subject was, when I was preparing the slides, I had to remove like 90% of what I wrote to just make it compressed for a 20-minute talk, but I think that I will write a blog post about it to have more information. So just, watch WarsawJS blog, and I think that soon there will be some article with more details on that. But for now, there are some resources that I advise everyone to read, those two RFCs that are related to creating network protocols. And as soon as you start thinking about, just creating some endpoint for your RESTful API as a form of designing a network protocol, then you have a lot of good advice that you can learn from. Also, the robustness principle from Wikipedia and the covariance and contravariance on Wikipedia. This is also something that I recommend reading. There are a lot of tools that I recommend using, like TypeScript, TypeScript, TS Essentials, and other things. You can see it later from the slides if you are interested. But there are a lot of good tools to make sure that you never crash on unexpected data, that you validate the data, that you always handle some things like that. There are a lot of good services to use, like Travis, Silco, Snyk, Codacy, CodeClimate, and another. There are a lot of good tools to make sure that you automate the process, that you can never forget about checking something. So make sure that always, you cannot merge pull requests when Travis doesn't say it's okay, and that Travis always runs your linters, runs your build, and does everything that it can to make sure that you never put any bad code into your master branch. So if you have any questions, then okay, I see some questions, so I think the mic will be there soon.
Okay, first question here.
Do you think if it's safe for frontend to generate TypeScript types based on Swagger or GraphQL?
Yes, this is a tough question, because there are like two ways to do it. Either you generate Swagger from, you can generate Swagger or some JSON schema from the TypeScript types, or the other way around. It depends on the project. Sometimes when you have a Swagger as the source of truth, then it's useful to generate your types from that. Sometimes Swagger is generated automatically from your types, and then it's sometimes more convenient to write your types first and generate, like JSON schema or Swagger data from that. But either case, I would recommend just having one single source of truth and the other one generated. So like you're saying, for example, to generate types from the Swagger, but then make sure that on every build you regenerate the types, so that you are always in sync with all of them, and you can always make it a part of the CI pipeline to make sure that that everything is up to date. But yeah, it's always useful to have it in sync automatically.
Second question, let's try with two more.
Okay, so I have one short statement about this load-get. So optional chaining in JavaScript is in stage 2 right now, so maybe you don't have to do this anymore soon.
Yeah.
And about so I'm using TypeScript, and basically I'm quite confident about my types if I am inside my application. The problem is that when something is from outside. And the question is it sane approach for you to basically have a layer between API and the front end, which basically has some joy validation or UP or whatever you find, with strict validation, which will basically check everything which comes from the outside and just throw an error if something is wrong, which could be less or more strict, because sometimes you might accept string or number if it's number in string or something like this. And extra question, does GraphQL do anything here better? Because I'm quite new in GraphQL. I don't know if it makes types more safe here.
Yeah, so it's definitely useful to have some additional layer to make sure that you are enforcing the validation or sometimes conversion, because in sometimes you want to validate and just reject any data that, for example, doesn't have any required value, but in other times you may need to put some default values there if the original value is not there. So it's easier to create a logic like this in a layer that is made just for that. And this is pretty much like validation middleware on the backend side. So this is on the backend side, most of the people are making like a layer like this, and they have like validators for every endpoint that are abstracted away. And I think in the front end is also useful. And just one thing to add is that in one of the projects that I've been working on, I've seen validation of the on the backend side, validation of the output before sending the response. So this is something I always recommend thinking about, that if you are writing a backend code and you are usually validating the input that you get, but when you have, for example, a Swagger definitions or JSON schemas, then you can also validate the output of the response of the on the backend side before you send it out to the client. And you can either just raise some exception if something is wrong, or maybe at least log the error or notify someone that something is going out that is not valid according to the validation rules. But yes, I think that those abstractions are very useful to put in one place and have it configured like you would like to. I don't know if that answers your questions.
Yeah, thanks. And about this GraphQL, does it make anything better?
It makes it different because the GraphQL itself can validate it in some ways, but you still, for example, if you have some string in the schema, then it can still be a bad string for you for some other reasons, or a number can be on the bad range of numbers. So there are sometimes more strict things that you have to do, but you pretty much, I would advise to have a strict validation anyway, even if you duplicate some of the validation that is done already in some other layer. I would still advise to have it explicitly done every time as well.
Okay, and last question from me. I'm a fan of abstract observations, and I have an abstract observation that everyone can exaggerate with everything. And my question is, have you ever spot a situation which you could call an over-defensing programming?
Over-defensive?
Over-defensive, yes.
Yes, I don't think so, really. It's usually the other way around. So it's usually, maybe I don't spot it because it doesn't cause any problems if there is something like that. So you never run git blame on things that are well. So, but I don't think that it could even be anything like this when I think about it. So, because what would be over defensive? I mean, checking every possible condition that can go wrong. I think this is like common sense, not over defensive. So, either way, I don't think that I've ever even seen much of the code that is checking for everything that should be checked. So we are on the other, part of the spectrum usually, to just checking too little, not too much. But I would be happy to work with a code that was over defensive.
Okay, thank you very much for this answer. Oh, one more.
I wanted to add something about the TypeScript and validating the outputs and validating in real time. Of course, as you know, there are the real runtime boundaries, so you cannot do it in runtime. But as you mentioned, Joy has a really nice type called typed.joy library, where you can create the schema in Joy and then generate the TypeScript types out of it, so you don't have to do it twice. Also, you have the library called runtypes, which basically do the same, and you can totally plug it in your UI front-end application. I had on this year InfoShare a presentation about TypeScript across the multiple layers. So if you're interested, check my Twitter. There is a link to the presentation. Little advertisement. Thank you very much.
Okay, so great applause for Rafał for this.
Thank you.